So again, put your name on this. We're going to do a little in-class activity number 1 through 9. You shouldn't need a lot of room, I don't think. Okay. Let's see. I think I got everybody's. Okay, so what we're going to do here, we're going to do a little in-class activity where we're going to try to see how well you can do here. We're going to see how well you're paying attention and how well you've kind of picked up on things. So here's what I'd like you to do. So number 1 through 9, name, period number on there. And what I'm going to do is I'm going to show you a problem up here. And I want you to put your honest opinion. I'll explain the directions as we go. I'm trying to use a little bit of time here until those knuckleheads get back from the bathroom. Let's see. I guess we're gonna start. Okay, all right, number 1, here's your first problem out of, there's 9 problems, ignore the 11 at the bottom. We're gonna go on to the next section after this, so. All right, so what you're trying to do, if you look at the top, what you're seeing here is the viewing window, okay? The top brackets are a viewing window. What I'd like you to do is pick which graph represents that viewing window. Now, let's talk about what viewing windows are one more time. So again, the little piece of paper in front of you, you need your name on it, you need your period, you need a number 1 through 9. So what you're looking at here is a viewing window. So let's talk about what do these 3 numbers mean in the viewing window. What does this first number mean? Say it? Yeah, the minimum X number. What's the second number? Say it again?
Y-axis.
Nope.
Oh wait.
Positive side of the x-axis. And what does the 2 mean after it?
Space in between them.
Space between them.
You said 1 through 9.
Okay, 1 through 9. So this, again, this is minimum x, max x, and the spacing that's going between every hash mark. This would be your y numbers. Minimum y, maximum y, the spacing in between them. Okay, that's what those numbers mean. What you're trying to do is figure out A, B, C, or D. Which graph represents that viewing window? Okay, I'll give you a minute. See what you can figure out. Again, this is just an in-class activity. Don't panic. It's not a quiz. This is just something I wanted to see if you were paying attention the other day and you understand what a viewing window is. Which one would represent it? Now, I'd like you to write down the letters. So on your first one, you're writing down A, B, C, or D. That's all you're writing. So lock in your vote here. You get a chance to vote. Okay, now don't worry if you get it right or wrong. You're still getting points. Okay, let's talk about it. Which one do you think it is?
D.
I agree. It is D. Now why? You're right. I agree with that. Let's talk about why would it be D?
Use your first brackets where it's -10, 10.
Yeah, so -10 up to 10, and what is it jumping by? 2. So -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. So it looks like it is going from -10 up to +10 on the x-axis. Then the second bracket. Minimum y? -4, and we're going up by 2's. -2, 0, 2, and 4. And it would make sense we went up to 4 by 2's. Does that make sense, the brackets that we're using? Okay, this is just one of those, like, you just have to see one for the first time, so don't panic. We have 3 more of these. I want to see how well you can, now that you've seen the first one, you kind of maybe figured it out and maybe it makes a little more sense now. Let's try the next 3, okay? All right, here's the next one. There we go. Okay, next one. You're trying to pick out which graph represents that new viewing window. Okay, same thing. View windows are X's and then the Y's are the second one. Figure out which graph represents it. A, B, C, or D. Write down your number, lock in your vote. Okay, somebody new now? Thank you. Somebody new, please.
C.
C, okay, good. Why? I agree.
Same reason, number one.
Yeah, same reason, right?
D.
You're going -5 up to 5, it's going by ones. So that's for the X, and then the Y is the same thing. They are respectable. Good, okay. Makes sense so far? Okay, good. Let's go to number 3. Same exact thing. Number 3. Whoa, that viewing window got really tiny. What happened here? I don't want this. I want that. No. Get out of here. Make that bigger, yes. Okay. A, B, C, or D. What do you think? So lock it in. Don't say it. Lock it in. See which one you think it is. Okay. Please.
A.
A. I agree with that. Okay, same reasons. A, let's go from -40 up to 40. It's jumping by 20s. And then the y-axis is jumping by hundreds. So, you know, -1,000, -900, -800, 700. You can get the idea and it counts up. Okay. Questions up to this point? Okay, last one of these, last one. I think you're on a roll now. Now you're getting a little more comfortable with this stuff. It's the last viewing window problem. Promise you. Then we're going to go to the table like we talked about yesterday. Just get the circle off the board. Okay, somebody new now? Thank you for those 3 volunteers so far. Somebody new once you think you got it locked in?
B.
Okay, B. Okay, let's talk about it. Why? Yes.
On the x-axis, it skips by 10.
Yeah. That,
20 goes up to
exactly. You could almost just tell by the x-axis alone. Just because it went from -20 and it's going up by 10s. And so it was getting to 0 real quick. So I could almost tell instantly by looking at the 4 which one it had to be, just because the x-axis was such a weird offset. Like all the others, if you look back at all the other problems we did, they're all like perfectly centered, but this one wasn't. It went from -20 up to 80, not like -20 up to 20. So that's what kind of like, it was quick thing, and then all you have to do is just check the 70s and the 30s for the y numbers. So just kind of an easy thing. I want you to see that. The reason why we have this type of thing is if you go on a graphing calculator, like a really nice graphing calculator, if you take a calc course in college, if you're fortunate to do one of those, they'll require you to have a graphing calculator. And sometimes it's nice to switch the viewing window. There is a view window button at the top row of the menu bar of your calculator, and it'll help you set your viewing window so you can just have your graph centered around a certain set of numbers. So maybe you can see the data just in that little pocket. So that would be like this is a perfect example of it, why you'd ever have to do something like that. Maybe that's where all the data is found. So, okay, questions with the first 4? Those should have been somewhat easy after you got past the first one. You had to get past that little breaking point. Okay, now, let's go to the next type. So now, completely different. I'm going to give you a table now. So here's your table. It has X numbers, Y numbers, and other Y numbers. So Y1 and a Y2. Okay? You have a bunch of different numbers. This is exactly a picture from my graphing calculator, so you can kind of tell. All right, so here's the question that you have. Okay? Here's the question. Does graph of Y2 pass through the origin? Does it hit the origin, 0, 0? It's a yes or no question. And then same question, does y1 pass through the origin? So it's a yes or no question. So this is your, what, fifth question? This is number 5.
They go both
Just,
ones.
they're both going on 5. You're gonna put the answers both on number 5. I have the numbers at the bottom, so I know it says 11. We're only going on 9. So this is your question number 5. There should be 2 answers here. Does your y2 pass through the origin, and does y1 pass through the origin? So it's going to be 2 answers. You can separate them with commas. I would assume that your first answer would be for the top question, your second answer would be for the second question if you're putting them in a row. Maybe add a little space and put them on top of each other. That makes sense visually. All right, let's discuss. So, what do you think?
First one's no.
First one's no. Why?
I don't know, I just don't know.
Okay,
But I know it's right.
you are right. It is definitely no. Now, let's help her out here. How do we explain it? Either one.
Because if we look at the x
Yes.
and the 0,
Yes.
the y2 has to have 0 the same one.
Exactly. Didn't, right? So its y-intercept was 0,2, not the origin 0, 0. So yes, so it was a no, for sure.
The second one's yes then.
Then the second one would be yes.
Zero's right.
Exactly. So then for the second question, it is 0, 0 for the y1 number. So that'd be your x and y. All right, so do we get the idea now? Okay, so the reason I pulled this problem out, it's kind of just nice to know that if you looked at a table of just data, could you kind of interpret what's happening here? At some point, did you pass and hit 0, 0 like for non-profit but non-losses? Did you hit right in the center of the graph? Or are you above the graph, like 0, 2 for y2? That was above the graph. You were always starting in profit. Maybe you lost it after that, but you started in profit to begin with. So little things like that, it's just nice for data interpretation. Okay, all right, let's go to the next one. So this now your question number 6. Same thing, still has the same, it's the same table. Okay, all right. Does y2 hit the x-axis? And where, if it does? Does it hit the x-axis? And where would it hit the x-axis? And the same question for y2, does it hit the y-axis? Yes or no? And if it does, where? Again, we're doing y2 here. So lock in your answers here. I'll ask for a new volunteer now. Thank you for the last one. So I'll ask for a new volunteer. Somebody that hasn't spoke yet today. Y2, does it cross the x-axis? And it does where? And does y2 hit the y-axis? And or where? So basically it's a big fancy way of saying, does it have an x-intercept and a y-intercept? That's a big fancy way of saying it. So, somebody new now that maybe hasn't spoke yet today. Okay, just tell me yes or no. Does it have an x-intercept?
Yes.
Yes, okay, it's out there. Does it have a y-intercept?
Yeah.
Yes. Now, I need to know where. Okay, give me one. I don't care which one you're going to tell me.
2, 0.
2, 0. Okay, so 2, 0. Okay, so 2, 0. What would that represent?
The x-axis.
X-axis. The reason why it has an x number, but it doesn't have a y number, so that's an x-intercept. That's how I can kind of tell. So it's hitting that part of the graph. Okay, somebody new now. Y-intercept? What do you got?
0, 2.
0, 2. Okay. And this would be your y-intercept, 0, 2. Because again, it has a y number, but not an x. It has 0 for an x. That's a y-intercept. So it did have both. So it had one of each. And that's another reason why y2 never hit the origin. It was hitting kind of above it and off to the side of it. So, just data interpretation. When I'm talking about y2, I can ignore the middle column. That's something that you just gotta kind of train your eyes to do, is just kind of, I'm ignoring the middle, because I don't need y or y1. That's just different numbers. Okay, let's do one more data interpretation. Okay, this is one more data interpretation question, and we'll get to the really kind of more challenging question after this. The last two are kind of challenging. Okay, at which points does y1 and y2 actually intersect? Where do they touch? And once you know where they intersect, you have to tell me the x number where they actually intersected. So did your graphs intersect? If they did, where? So y1 and y2, they're individual like graphs. Something's happening here with both data. At some point, they did cross. What was the coordinate where they crossed? Okay, got one?
Negative 2, 4.
-2, 4. Perfect. There's the coordinate where they crossed. That's one of them. The reason why both of them had -2, 4. So somehow, whatever's happening on these two graphs, now one graph's doing something like that, one graph's doing something like this, so at -2 and 4, they were both touching. That's an intersection. That's what's happening on that. Okay, another one, please.
1, 1.
1 comma 1. There's another one. 1 comma 1. So maybe my graph was wrong here. Maybe it was something like this. Maybe that's 1. So they're hitting at 1 comma 1. So the x number where they actually equaled was 1 and -2. Those x coordinates where they actually matched. Okay, questions with that? Okay, it's kind of nice to know, are your graphs intersecting? Maybe what you're trying to find is, maybe you're looking at, the loan that you're paying off, and you're looking at profits and losses, and you're trying to see, okay, for a while, will I be above my payments? Will I make more money than what my payments are, so I'll actually be in profit for once? That's a big deal for businesses. If you're taking out a major loan for your business to get it started, and you know what your loan is, so you know how much you're paying every month, and you can kind of plot that on a data point, how much you're actually spending on your loan total, and at some point you need to plot what your sales are and see when it crosses. When did I actually pass the amount of point where I've paid money in? Will I actually make profit? Because if you're not going to make profit for a year, can you even sustain your business? Maybe you don't have that type of cash. Like, you looked at all the data sets you have and you're like, holy moly, I'm not going to be profitable until like November of next year. I can't support this business. I can't keep paying out of my pocket. So it's one of those things you just gotta check on it. Okay? All right. Questions with all those questions up till now. Okay, now comes the tough questions. These are the ones you're gonna probably need a little more time on today. Okay? These are the last two. Okay, same table as before. Same table. Now I want you to come up with the equation for y1. The equation for y1. I want to know what equation is it. Is it A, B, C, or D? Don't yell it out. Write down and lock in your vote. What you think it is. You're trying to figure out which equation would represent the data for y1. This does take a little bit, unless you're really good at guessing. Anyone need more time? All right, now, before I ask for the answer, I want you to walk through the strategy I would use if I was like an ACT trying to do this super fast, because I've taught you one way how to do it, right? I've taught you, the strategy I used in class the other day, just yesterday. I told you to take all the X's kind of one at a time, plug them in to each one of these one at a time, and see if it will always give you the right answer out. So you have to kind of plug in all the numbers into that, see if it works. If it fails, just move on to the next one. Plug them in all here one at a time, see if it works, and plug it in, all right? Now, that's great, that's a good strategy. It takes time though. I would try to quickly eliminate things that I know. What I mean by that, I would start with the number 0, and I would try the number 1 first. The reason why is I can eliminate a lot of these by just throwing those numbers in first. Okay, so what I mean by that, if I plugged in 0, right? Because for y1, do you agree that if I plugged in 0, it needs to spit out 0, right? If I did this and I plugged a 0 in here, would it spit out 0 for a y? No, that one's gone instantly without even having to check any other numbers. And the other one that would be gone, right? If I were to plug in, let's say, the number 1, right? Because I would always try the easy numbers. If I tried 1, this one's gone instantly. Because if I tried a 1, this would turn out to be a -3, not a 1. So I can already eliminate 1s really quickly by doing that. Now the next thing I would do is now try the last 2. And the ones that I'm looking at is probably the square term, probably B. That's the one I'm going to look at first. And I would try to square the numbers. Square a -3 gives me 9. Square of 2 would give me 4. It's B. I can eliminate things within a few seconds without having to check every single number, if that makes any sense to you. Okay? Questions with that? Remember, when you square a number, it turns positive. Letter C, all the numbers would be negative, because you have to square the number, then put a negative sign out front. So that's a kind of an evil one. All right, last question, then we're going to turn this little piece of paper in. Last question of the day. Same chart. Now we're going to do it for y2. Find the equation for it. And I'll ask for volunteers on this one. Sorry, I didn't do that last time. I just wanted to walk you through my strategy for quickly figuring out these things. So now you're doing it for y2. What is the equation for y2? This is the last question. All right. Anyone need a little more time? Okay, what do we think? Answer, please.
C.
C. I agree. Why C? What's the number I would check first?
Any of them.
I would check 0. I check 0 first, every time, right? I start with the easy number. Start with 0. I know that you should start with every number, but check 0 first. 0 for y2 should give me 2. So if I plug a 0 in here, will that give me 2? Nope, that one's gone. If I plugged a 2 in, or if I plugged a 0 in here, that would be, okay, so that one's a good one. That's the right answer, by the way. But if I plugged in a 0 there, that would give me a -2, so that one's gone. And if I plugged a 0 in there, it'd give me 1 minus 0, which is 1. So right away, I figured out in the first second which one it should have been by plugging in 0. 0 is the easiest number to plug in. It cancels out things. The next number I would check is always 1 or -1. Just that's my little strategy that when I start those, especially like an ACT or a MAPS test or a, whatever college entrance math test you have to do, I would plug in just a simple digit first to see which one quickly gives me the answer. And I always start with the middle number. All right, questions. Okay, I'm gonna take those. I want your name on it, period number on there. I think it's kind of important that we do this. You get a little practice at it. You get to get thrown in the deep end without having to do homework. You get some easy points today. It is a Friday. I want to take it kind of easy today. We have homework due today, so just make sure of that. You have worksheet, it was P.8. I think at the top it said P6, sorry. I probably should have fixed that.
You.
All right. Okay. All right. So here's what we're gonna do last. So this is why this thing went up to 11. I just needed a graph, so I'm just gonna pop one of these up here. All right. Let's get rid of this. I'm gonna super zoom in on this thing so we can use the graph on it. Okay. What we're going into in this next couple sections is we're going to be graphing, types of functions, polynomials eventually, and we need to talk about the rules for doing it. So I'm going to freeze that on the board so it doesn't go away here. All right. So to graph on like one of these, on a Cartesian coordinate plane, let's say it's some type of function. Okay, I'll just kind of give you a random function here. Something like this. And I ask you to graph this. This is what we're going into these next couple sections. The book has some different strategies for when they just give you some random function and say, hey, go ahead and graph it. Okay, if you were really good at Algebra 1, you probably recognize that that problem was a linear-based problem. What gives it away? Does that problem contain any powers? Like powers of 2s, 3s, 4s, no. So it's a straight line, like automatically. There's no powers, it's a straight line. And then what Algebra 2 and Algebra 1 would teach you is, which formula is it? How do you graph it really quickly? Fine and dandy. If that like memory bank fails you and you're like, God, I don't remember how to do that, there's always a second strategy. So if you don't remember the specific formula, by the way, I have the formulas over there. If you don't remember the specific type of function that it is, you could just plug in numbers, like digits, one at a time, and then go plot it. So what I mean by that, you can just pick small numbers. Pick like 3 numbers right now. Any 3 numbers you want, keep them small.
2, 7, 8.
2, 7, and 8. Okay? Okay, those are bigger numbers than I was expecting you to tell me, but okay, we'll do it. Okay? Now, what I would do is I'd go plug those in. So I would plug in 2. What's 3 times 2?
6.
Plus 1? 7. There you go. So that's your x that you plugged in. This would have been the y that spit out of it. Right? If I plug in a 7 here, what's 3 times 7? 21 plus 1? And 2. Plug in an 8. 24 plus 1? Okay, you can do that and then go plot them. Okay? So I have 2 comma 7, 2 over 7 up. And then what is that? 7 comma 22. And then you get the idea of where that thing's going. You could do it that way. I would have picked 0 and 1s, but I didn't expect you to pick 7 and 8s. All right, but it works. You could do it. It would plot out your data, right? You could see it really quick that it's linear. Now, that's if you don't recognize it. You can do that for any type of formula, any one, even if there's squares, powers, weird things going on. Or, if you have to remember some of the skills they taught you in Algebra 1, you would recognize that this formula is in slope-intercept form. It's on the board over there, you can see it. Slope-intercept form. What this means is it has a slope Slope is the way that the line is tilted, right? It's rise and run. It's the change in y's over change in x's, delta y over delta x. It's an average rate of change. Yeah, so it's just kind of, there's a bunch of terms for it. It's, they use m, but this is your 3 over 1. That's rise and run. That's great. I can tell where it tilts. I go up 3 and over 1. I always go to the right when I draw a slope. Now, the 1 in the back is your y-intercept. It's where it's like a starting point. It's where you hit the y-axis. It's always that number. So I'm going to hit positive 1. I did not draw my line correct at all. Way more tilted than the one I just drew there. But I start at 1 and I go up 3 and over 1. Up 3 over 1, up 3 over 1. And I get a sense for where this line is going. It's going that way. That's if you recognize it, okay? What I'm going to teach you in the next couple, bless you, in the next couple sections, what we're going to really hammer down is no matter what function I give you, whatever formula I provide you, I'm going to teach you the shortest way possible to graph these things and the quickest ways to do it without a graphing calculator. And I'm not telling you that, oh my God, there's all these formulas and things you need to memorize. No. The strategy I'm going to give you will work on any function, any size, as long as you are capable of doing the type of math we've done the last couple days in here. So it's really slick. It's not going to be an exact science, but it's a guideline to help you draw super quickly. So if you are on an ACT, I could give you a rough sketch of this thing and then pick which one it's got to be. And that could help you predict, what the answers would be down the road. So that's the strategies we're going to learn. Okay? Is there any questions with what we're going to be learning the next couple days in here? Okay, so Monday, we're going to start hot and heavy on this stuff. I'm going to give you different functions, not just linear. I'm going to give you curves and other things, and we're going to start to learn the process for graphing. This is going to be some serious pre-calc stuff, okay? All right, so that's it for today. We're done.